So welcome again to any new people that have been able to log into the room. Today we'll be talking about lowering OPEX costs for PV projects. My name is Eric Swenson. I'll be the moderator for this webinar. And the speakers today would be Ignacio Roman, Product Manager at Isotrol, Jose Alfonso Teruel, R&D Director at Soltec, and Irma PNR, VP of Supply Chain at Scatec Solar. And we would encourage you to ask questions, put your questions in the question and answer box rather than the chat box, if at all possible. And what I'd like is we will, first I'd like the three presenters, starting with Ignacio, to just a brief presentation of themselves. And when that's complete, Ignacio, you can begin your program.
Okay. Hi, everyone. Firstly, I would like to thank you for your time. My name is Ignacio Roman, and I am Product Manager in Isotrol. I'm connecting from Seville, at the south of Spain. I work in the company for more than 16 years, in which I have carried out a large number of projects to integrate control and management solutions for renewable assets. Since I began, I have worked as integrator, product manager, pre-sales engineer, and finally as product manager in these last 2 years. In all these years and projects, reducing operational costs has become more and more important. So in collaboration with my colleagues and clients, this is one of the main targets we try to arise. So we have been working on it in many time ago.
Okay. Jose Alfonso.
Hello, everyone. This is Jose Alfonso Teruel from Soltec. I'm here from Spain. We are a solar tracker manufacturer with more than 14 years of experience. I've been working for this company already for 12 years, almost, and then the R&D manager in the company. We are constantly developing new technologies for trackers and for large-scale PV plants, all integrating the latest technologies to the trackers, to the plants, lately the bifacial modules, and many other technologies that we are to come for the next years.
Irma.
Hello, everyone. I'm Irma Pinar, work for Scatec Solar, Head of Supply Chain, Global Responsible. Scatec Solar is an integrated IPP. Typically, I'm based in Cape Town. Currently, I'm calling in from Oslo, a very cold Oslo. And yeah, I will say a little bit more about the company during my presentation.
Excellent, excellent. Very good. Then without further delay, let's see if we can get started, Ignacio, with your presentation. You'll need to unmute and start video. There we go.
Okay, here we have my presentation.
Can you do it full screen, please? Okay.
Okay, it's okay.
Yeah.
Okay. In this presentation, I will talking about Isotrol experience in lowering operational cost in PV portfolios through the automation of processes using IT tools. Firstly, I would like to make a brief introduction about Isotrol. Isotrol is an engineering and consultancy company specialized in control and management system with over 20 years of experience in renewable energy sector. Our management system have been integrated in more than 1,500 renewable energy installations and are used in the operation of more than 25 gigawatts around the world. Isotrol has more than 250 employees. Its main headquarters is based in Seville, in Spain, and we have office also in UK, USA, Argentina, Chile, Mexico, and Brazil. And our clients are the main market players, and they are companies with different profile as investment funds, IEPC, O&Ms, owners, utilities, and so on. Bluens is the brand for Isotrol solution and services for the renewable energy business, including a large list of products for monitoring and control, technical supervision, operational efficiency, economical management, and of course for maintenance management. All of this under the same main target to enhance our clients' profitability. Okay, to be able to understand the current situation, it's necessary to review the history and analyze how the business has evolved, and more specifically, the needs and requirements of the operation and maintenance. Analyzing the business, there was an initial situation in which there were bonuses and preference to renewable generation. But this scenario has completely changed, mainly because of the participation in the renewable energy market. This change in the market has triggered the evolution of metrics to control and tracking the business efficiency. Initially, it was enough metrics related to the contractual objectives of availability and performance ratio. But nowadays, it is necessary to search for an energy optimization. In other words, to produce the maximum when the energy price and the resource are the highest, and of course with the lower operational costs. In order to achieve these objectives, is necessary an important evolution of the management tools. Initially, the monitoring tools didn't have enough functionality for an automated management that allowed to reduce the operational cost. In addition, the use of CMMC system was not very common because they are not specialized in the PV business. For this reason, it's growing the necessity of new integrated tools that optimize the maintenance and also have the metrics to track the profitability. Focusing on the problem, prices have become more and more competitive, forcing owners to search for solutions to balance their profits. This is when the management tools can help to reduce operational costs and increase revenues. From Isotrol, we have worked in 4 areas to analyze and design a solution that helps to lower operational costs by optimizing maintenance. These points are control system. This system don't have the necessary functionalities to optimize maintenance management and to do it with automatic mechanisms. Second one, commercial CMMC system are not adapted to the PV business. At this point, our experience advising clients has shown us that these tools are very expensive to integrate, basically because they have to be adapted to the particular characteristics of the PV business, like distributed installation and distributed warehouse, the dependency of an unpredictable resource, complex and multi-technological elementary, so on. Once integrated, they are not automated enough, requiring an excessive effort to register and exploit the information. Third point is forecasting. resource forecast published by forecasting services is used to other issues, like to improve the market offer or to comply with the obligation established by some grid codes. However, little tiny is used to improve maintenance planning, and it is not done in an automatic way. And the last one, predictive of failures. The system are evolving a lot thanks to new technologies of big data, artificial intelligence, and machine learning. But the result of these advanced algorithms are not being used to propose automatic actions in maintenance. So, based on our experience on the market trends and on our clients' problems, Isotrol is working on a value proposal that incorporates additional functionality in the control and management system. These functionalities are the integration of forecast information and its use for maintenance planning, the use of the results of failure prediction algorithms for a better maintenance planning, allowing preventive and palliative actions to reduce unavailabilities and production losses, and integrate functionalities to manage maintenance in the control system, allowing the users to manage maintenance in a guided and automated way. These solutions allow us to obtain improvement in three fundamental areas of maintenance. In corrective maintenance, with an optimal management of warehouses, resources, personnel, work procedures, work reports, indicators, and so on, we can achieve an increase in efficiency and a reduction in operational costs. In preventive maintenance, with the forecast of resource and prices, a better planning of maintenance is possible, and better planning of action can be achieved, which will allow us to reduce unavailabilities in periods of high profitability. This leads to an increase in income. Finally, on the predictive, the early detection of problems that affect the production and availability allow us to schedule corrective or palliative actions to prevent the loss of productions by uncontrolled unavailabilities. This way, we obtain both improvement, a reduction in operational costs, and an increase in revenues. Here we have gathered three real experience in which we have applied this proposal, this solution. The first one is a centralized platform that manages a portfolio of more than 1 gigawatt. The solution is to integrate the monitoring and control system with the GoM tool, that is the Isotrol solution to manage the maintenance of renewable energy plants. The improvements obtaining has been the reduction of inefficiency in the maintenance activities, because the system lets technician knows what the problem is and where the failure is located, the material or spare parts that they will need in the reparation, the individual protection equipment they will need, and so on. And also the priority when several problems occur at the same time. We also obtain a reduction of time to stock spare parts and consumables by the automated notification sending when the breaking point of the stock is reached. All of this has reduced contractual penalties and increased the profitability of the installation. The second case is a centralized system for a portfolio of 800 megawatts. A centralized monitoring and control system was integrated and connected with a system that provides early detection of performance problems and breakdowns. So To know the problems before it occurs, allow our clients to take corrective actions before uncontrolled unavailability occurs. This allows to have a reduction in downtime. On the other hand, the identification of low performance has made it possible to review components that were not working properly. This has made it possible to increase the overall performance of the asset. And with all this, it has been possible to have an increase in income for the same resource, for the same average resource. The last one is a project that is currently in process, in which we have a portfolio of 45 assets and 900 megawatts, more or less. The monitoring and control system has been integrated with the GoANM tool and has been integrated with forecasting information from an external system. This is enabling maintenance planning to be optimized because based on base planning configured by the user, the system proposes alternatives according to the state of the plan, according to planned resource, and according to the priority of the rest of the planned works. The aim is to reduce the impact of maintenance activities on generation. So, in conclusion, one way to achieve maintenance optimization is integrating into a unified system the monitoring and control processes, the maintenance processes, and the prediction, both resource and problems. So, the final conclusion is that to optimize maintenance management is necessary to reduce operational costs. And a key factor to achieve it is the automation of processes and activities. However, our experience has shown us that maintenance optimization not only allows the reduction of cost, the integration of processes also allow to integrate the income, to increase the income, sorry. At the end, enhance the profitability is possible. That is all. If anyone is interested in more information, here you have my contact details. We will be happy to assist you. So please feel free to contact with us. Thank you very much for your attention.
Thank you very much, Ignacio. That was a very interesting presentation. I think a lot of people would be very interested to get additional information as far as the increased profitability, which we're all looking for. So that's very nice, and hopefully people can add their questions either directly to you or for all the panelists in the Q&A section of the room. Our next speaker will be Jose Alfonso, and Jose, when you get a chance, go ahead and load your presentation and begin.
Okay, thank you, Eric. I will start sharing the presentation. Okay. Okay.
Great.
All right. So I will speak about the impact of PV innovations on the operation and maintenance of a solar plant. Okay, all around the tracker design. Initially, I will talk about the company. Soltec, as I said before, has more than 14 years of experience in PV plants, specifically in solar trackers. And we have been, we are specialized in manufacturing single-axis solar trackers for utility scale PV plants. We are a company based in Spain, but we're an international company with many subsidiaries around the globe. We have more than 1 gigawatt of annual sales of trackers, and we are the top 3 in as a global tracker supplier in 2017. We are the number 1 in Europe, and our main product that has been deployed during the last year is the SF7. It's an optimized single-axis tracker, which the design has been mainly driven for the optimization of the operation and maintenance costs and the installation times and costs. Okay, this tracker has many advantages. It's an independent table tracker. Each tracker is moved by a single motor and controller, and this allows many advantages for operation and maintenance. Has self-lubricating bearings, which never need to be replaced during the whole life of the tracker. Has sealed slew drive, which is the mechanism that moves the tracker, and doesn't need any operational maintenance also. And everything allows for a guaranteed availability of our trackers over 99%. One of the main features of our SF7 tracker is that it's a self-powered tracker. Okay? It's self-powered with our unique solution. It's a patented series power supply that allows the highest energy availability. The main difference of this power supply versus the competence is that we power the trackers from the strings that are on the tracker, from the PV strings, and we connect our electronics in series with one of those strings at any point of the string. And that's the uniqueness of our solution. With that, we have plenty of power available, and we can control what to do with that power. In our case, what we do is to charge batteries. Later, we have provided peak power to the motor, and also for the electronics. Okay. Another product around the SF7 is the DC harness string runner. This is a proprietary standard solution unique in the market. It's a modular plug-and-play cabling solution integrated with the tracker. It uses the torque tube in the tracker to run the trunk cables through it. And the main advantages is that we use fewer parts, less cables along the trackers, lower material cost because we are concentrating all the string cables to a trunk cable, and lowering the installation labor with this plug-and-play solution. It's very modular. Each tracker has the same components, and it's very fast and easy to install. Our trackers have wireless communication, and we implemented a hybrid radio and RS-485 communication system, eliminating up to 90% of the wired communication cable. What we see in this picture is the central line of trackers. Those trackers have a cable communication to the gateways, and then each of those trackers establishes a mesh network with the surrounding trackers, and all the surrounding trackers are wireless trackers. This is a compromise between speed and wireless mesh, allowing the very low use of cable and high-speed data rates. Each gateway can update the information of all the trackers in less than 30 seconds. We also have NFC communication at tracker level for operation and maintenance purposes, where anyone with an Android mobile can go to a tracker level and place the mobile and get information, and also send commands to the tracker. And then all the communication is integrated in the SCADA interface at plant level. The team track is another feature of our trackers. It's a backtracking control that allows each tracker to go to an optimal position in order to avoid shading, inter-row shading in the trackers, and having in consideration all the slopes in the regular terrains in the plants. So as we see in this picture, each tracker has a different angular position. This command for each angle has been controlled from the central SCADA of our trackers, where we concentrate all the information of the position and slopes in the whole plant as a whole. So what we do is to get to the optimal position for the whole plant, not for each tracker individually. That's why the name is team track. And also very important for the operation and maintenance is the cleaning, how we deal with the cleaning of our trackers. Thanks to the wider islets in our trackers, so we have more space between tracker rows, so we get greater access for cleaning purposes. We can move our trackers in a face-to-face position, allowing easy access and higher cleaning rates, as we can see in the picture. A big vehicle can run in between trackers and clean both sides simultaneously. Our trackers are also compatible with water-free and automated cleaning solutions for utility-scale solar plants where the cleaning is required more frequently. In some locations, require everyday cleaning, and this must be done automatically. Lately, we are working with several robots companies, and we are integrating their solution with our trackers. The idea is to allow the robot to move independently for the most numbers of trackers every day. We also have snow load dumping. In some cases, we provide sensors to measure if it's snowing or not, and to know what's the snow load in the plant, and we can move the trackers for a safer position. We can also program a night position for self-cleaning, and what we do is to move some days to the east, some days to the west during the night, at night. And this allows cleaning, homogeneous cleaning, self-cleaning every day. And this can be programmed according to the time, according to the solar position. And the last development that we are announcing lately is the SF7 bifacial. We have this is a specific design for bifacial modules, which avoids the shadow of the structure or cabling affecting the backside of the panels. This is very important because it reduces the risk of mismatch in the strings and potential hot spots. Some studies are lately announcing that the back shadows for bifacial modules can produce hot spots and can reduce the yield of the plant, and also in some cases it can affect the life of the modules. What we see here is the difference between our trackers, which are 2 modules in vertical versus the typical 1 module in vertical. Our trackers are higher and the distances between trackers is wider. And this is helping the modules to be at the lower temperatures. And this is affecting also the performance of the plant. And this is the way we do with bifacial. And that's all. Thank you very much. If you have any questions, I would be happy to answer.
Thank you, Jose Alfonso. That was very interesting. I think that some of those things that you mentioned as far as maintenance and automatic cleaning and things may generate some additional questions. So make sure you check the Q&A at some point. Now, Irma, if you could get your presentation up and running, we'll all be interested to hear what you have to say.
Thanks. Yes. So from Skatex Solar, head of supply chain, and basically just a little bit about Skatex Solar. We're an integrated IPP, and we're focusing on emerging markets. Currently, we've got around about 360 megawatt in operation, 1.1 gigawatts under construction, backlog and pipeline of 4.3 gigawatts, and we're targeting to have a capacity of 3.5 by the year end 2021. So how we create value is through developing projects, financing projects, building the projects. We don't do external EPC, we only do EPC for ourselves. Then we own and operate the projects, and then obviously we own the projects for the lifespan of the projects. So we have a keen interest in lowering the cost throughout the entire value chain to maximizing profits. So what we typically see is that at this point, when you go into the operation phase, you can only optimize what has already been decided and installed. Where you really can lower and influence OPEX is at this point before construction. So we have got different departments working in these phases, and I think there's a healthy strain between these departments, pushing each other to do better. The development colleagues, they want to maximize yield and lower the cost in construction and operations. So it's always a healthy fight between the departments. So I'm just sharing briefly from experience what we try to focus on to help each other throughout the value chain so that no one inherits high OPEX. So if we look at the procurement of the major equipment, I think there's so many module suppliers in the market, and it's really important to have a holistic product view. It's not just enough to look at the certification and to make sure that you get a module out of the factory. You need to have a look at the junction boxes, the back sheet, the bill of material that's going to be used during production. When you procure, you need to consider if you're going to buy a glass or a frame module, it has an impact on the OPEX. You already mentioned bifacial, and typically bifacial comes in glass, also now leading towards a frame bifacial. But the breakage rates and the training associated with replacing is something to consider. Obviously, you get a 30-year guarantee with a glass module, which is also quite nice from a production point of view. Supplier bankability in the current market with low module prices is a concern, so might need to look at having some additional insurance with that. And then I think the one thing is where everyone's always fighting, and it's actually such an easy thing to settle, is the inverters. I don't think it has any sense in pushing down the capex of your inverters if you're only going to push up your OPEX. Inverters are typically around about 5% of the module price, of the capex price, and it's got a huge influence on your OPEX. So it's basically the brain and the heart of the plant. And you need to consider to make the right capex decision because it will influence your OPEX. Then you have got your inverter string versus central inverters. I think for OPEX, a string inverter is very nice. It's still a little bit more expensive on the capex side. So that is something to consider. Substructure, obviously fixed tilt is preferred because you put it in position and you basically have very little maintenance. But when you go to the tracking system, there's moving parts. I think Jose covered it quite nicely with Soltex tracker. But then you have your common drives where you've got one motor driving several parts, and then you've got your single drive system, which is the SF7 that we've looked at, which you have more motors to maintain. So it's important looking at sealed units and making it as closed system as possible. You also mentioned the self-power trackers, or DC tracking as we refer to it. Important as the battery prices are coming down, it's becoming more and more feasible, because at some point you will need to replace these during the operations of the plant. Quality control during construction at suppliers and on the construction site. If an operational plant inherits bad cable terminations, the structures, after they've been rammed, they don't get cold galvanization. You can sit with some big headaches of the project. Simple things like cable tie replacements. If you have to replace 500,000 cable ties, it can become a big headache. So making sure you get the quality material into the project. At the module manufacturers, we've got 3 different levels of inspections depending on the qualification of the supplier. So we can go up to 24 hours inspection or weekly inspections depending on what we see. But it's extremely important that you get a quality product out of the factory that you're going to install on your projects. One of the good things about our model is that we also have an influence on the design, so we can design from the beginning with OPEX in mind. Looking at drainage systems so we can avoid ponding, building the access road so that the equipment is easily accessible, and already mentioned the string inverters versus the central, but we also can look at string versus inverter level monitoring to make sure that faults get detected easily and you can easily integrate it with the data capturing for the CMMS systems. Swelling considerations: if you're planning on robotic cleaning, whatever cleaning you're planning with, it needs to be planned up front. Make sure you've got the right level of water at the site. Yeah, the robotic cleaning needs to be integrated in the design if you're planning with that. So to achieve all of this, we've moved from having a supplier purchaser mindset to going to a partner mindset. We work closely with several companies, suppliers, to do some innovation, to improve delivery, cost, quality. And we have a continuous feedback loop to improve each other's business. And then we get to the tweaking of the OPEX, where we look at spare part philosophy and strategy, the training of the staff, availability guarantees, product warranties. So I think that's one important thing that I didn't probably mention enough, is that you have the negotiating power when securing the OPEX, of the CAPEX of the park. So no one is really interested in negotiating after you've made your big spend. So as part of your CAPEX, you need to secure your strategy for the warranties, the training, the availability guarantees, to make sure that your O&M team is sufficiently supported. Staffing requirements: the better the equipment, the quality of the project, the accessibility, you can reduce staffing requirements. And then I think the big buzzword is obviously big data and how we use that to drive continuous improvement and optimization. And that's it from my side.
Very nice, Irma. Thank you very much. I trust and I hope that all of the participants got some benefit out of the 3 speakers. I think they presented very interesting information. And right now, I think we'll begin by looking at some of the questions that have come in. And there's one that's shown that says, hi, I have a very specific question. Not sure if it can be answered. For one axis tracker, etc. It goes on. And I was wondering if all 3 of you could give your answer live to those, maybe starting, well, whoever wants to start. How about you, Ignacio?
Okay, in this situation for bifacial modules, we don't have any experience at this moment, so we don't have any measurement about how can we affect the OPEX. So sorry, but as Modesto said, cannot be answered at this moment.
Jose, any input there?
Well, I don't see the framed or frameless modules, bifacial or not, will have any impact on the OPEX. For bifacial modules, as I said in the presentation, it's important to leave the back side of the modules open, free from any obstacles, from any shades of the structure. If we respect that for framed or frameless modules, it will be the same. One thing to consider is during the installation time, we have an experience of taking much long time and being much more difficult to install frameless modules than framed.
Okay. Irma, anything to add?
Yeah, I think for me, the big thing, as we're currently installing a lot of bifacial, the big thing would be the backside cleaning. It's not directly linked to the glass, but it is specific to bifacial. The clamping it can be a nightmare if you need to integrate it properly with the module supplier and the structure provider. Make sure that especially if you're using a bifacial, that it doesn't overlap the cells, and that the rubber that you use is of sufficient quality so that the module doesn't slide out over a period.
Okay, very good, very good.
I think there was another question about that a bit later on, so I'm hoping that we answered both of them at one go.
Yeah, I see there's a question about using module level monitoring like Solar Edge or InPhase, specifically to you, Irma.
I was just typing the text, but I can answer it directly as well. I think that's something that's recently piqued my interest quite a lot. Because the one benefit of string inverters is the quick replacement and reducing downtime. And if you even go to module level, it can be quite interesting with regards to plant availability. Whether it's feasible at this stage for utility scale, I don't know. But I think for rooftops, it could be very interesting and smaller installations.
Okay, very good, very good.
I think, just to add on to that, I think what's needed more in terms of the investigation of that is the repair philosophy, if you can repair it, or if there is a quick replacement to that, or whether you have to discard the entire module.
Right, very good point, very good point. I see there's a question to all the panelists on any best solution for cleaning bifacial panels. Maybe if each of you could weigh in there if you have bifacial panels in your repertoire. Jose?
I can't answer that question right now because it's something that I haven't found a good solution for it yet, specifically for trackers. So I don't know what will be the answer for that. For the top side of the panels would be the same, automated solutions, but the backside is more difficult.
Also, I can say that we haven't implemented robotic cleaning to date, purely for two considerations. I think it's still a developing technology. And the other part is where we want to make an impact in the communities through job creations. So what we're currently doing with our bifacial planning is we are planning manual cleaning on the backside. I think the backside needs much less frequent cleaning than the front side. So depending on your environment, you might not need it at all. In some cases, you might need it, but much less frequent than the front side.
Mm-hmm. And I see a question in the chat box that popped up, and it says, except for multi-point tracking, I do not see any specific advantage of string inverters. And he asked you, Irma, but I suggest maybe all three of you could weigh in on this to confirm your view. I know there is a lot of discussion, if you look on the internet, on string inverters versus single micro inverters on each panel. Maybe Ignacio, do you have anything to add there?
Okay, is certainly string inverter provides said that is more the string inverter have more an optimal maintenance, because if you have a failure on a string inverter, is easy to repair and substitute the equipment. At this moment, we only have 2 or 3 assets in which we monitoring string inverters, and we still don't have the results or the indicator about if this is true or not, but we are able to have measurements about if this cost is lower or not, comparing with the industrial inverters.
Mm-hmm.
Mm-hmm. Jose?
Well, what we see a trend lately of installing more and more string inverters in the utility scale PV plants. They have the advantage of having more maximum power point trackers that may lead us to a higher yield of the plants. And also, as Ignacio said, that they are easier to replace, easier to repair. So I see this, it could be a good advantage. And lately, the cost of these string inverters is compared to central inverters is very similar. So
Yeah.
And they are selling in very large volumes. So I see that for the next year, or the following years, they will get more and more market.
So I think what both of you are saying is that, you know, string inverters, my understanding is with the string, if you lose the inverter, you lose a whole number of panels, versus with the single inverter, obviously you don't. But it seems that you're saying that the maintenance costs to repair a single individual one is higher than the ease with which you can repair a string inverter. Is that, am I correct in that?
Yes, and it's easier to repair, and also the power affected by any failure in those string inverters is much smaller.
Okay. Irma, did you have anything else on that topic?
Well, I think on the EPC side, the lead time for string inverters is obviously much shorter, and it's easy to keep a lot of them as spare parts. So it's quick replacement, less downtime, less of the plant affected. So yeah, I think those are the main benefits. From my point of view, the CapEx is still a little bit higher, but I think it needs to be seen in the bigger picture. And I think you need to look at the specific products and specific suppliers. It's not one is not equal to the other. All of them have got their specific advantages that you need to consider individually. Also, the remoteness of the plant. If you've got a very remote plant in the middle of Mali, string inverters might be a recommendation.
Okay, good. That's very good. I think it's helpful to the participants. I noticed there's a question on the chat that says, "What is your view on performance guarantees using a PVS syst as part of the O&M? Do you have any recommendations or alternatives?" I think you all each spoke a little bit about performance. Any specific things, Irma, on that one?
Well, obviously, I think the main input into when you establish your base case for your performance guarantees would be a PV syst, and then following that, you need to have very accurate metering equipment, which is a very, very important part of the PV plant. I think PV syst is just the industry standard accepted. I know that there are other tools available, but if you're working with international lenders, etc., I think that is basically the accepted.
Okay. Jose or Ignacio, anything else to add on that topic?
Okay, I know PVCs, but I don't have any experience with this solution. But obviously, any IT tool, of course, better is this isotrol solution. Could be able to monitoring and tracking the compliance of the guarantee,
Right.
the performance guarantee. So. IT solution have to be necessary for check the compliance.
One of the things that you all talked about in certain sense was items that affect unavailability. Do any of you have any data that you could share on the webinar today, as far as what are the major things that you're finding in your operating plants that causes unavailability?
Yeah, and I think the inverters play a major role in the availability. Well, simple things as having correct calculations up front in terms of the derating, the heat, the actual environment that you're going to install it in, and then the product itself, and then your maintenance strategy around that. I think one of the things that we implement to reduce the downtime is also to have our plant technicians trained up to the supplier technician level, so they can do more themselves on site. You don't have to wait for the supplier to come out to do the repairs. They can do a lot of it on site themselves with the sufficient spares. The tracking system, I think the single row tracker, unlike the SF7 from Soltec, is very good, because you only lose one row when the motor goes down. If you've got a common drive tracking system, you can lose a whole block. So that's an important consideration. Right. And also, just if your surge, your protection system is not good, and you have lightning strikes, etc., that can also have quite a big effect. And then swelling, it's not directly availability, but it's to do with the performance of the plant. So you need to have a very good strategy on cleaning and make sure that your plant is performing properly.
Right. Ignacio, I think you were going to weigh in there.
I would like to add that regarding unavailabilities, sometimes in PV plants is difficult to differentiate if loss of production is due to an availability in some string boxes and some strings, or is due to a shadow. So it's important to have an intelligent system that are able to detect the root case of the low performance, low production, in order to optimize the actions to correct the problem if there is a problem.
Jose, anything else on that one?
Yes, well, Irma mentioned all the possible problems that we may find in the installations, specifically for trackers. Lightning can be a problem if we don't have the proper protections installed in the plant, and also the grounding of the plant. In some cases, if it's not good enough, can affect the whole plant. I mean, all the electronics. Can be noise everywhere. So we see a big differences in plants with the same product, where due to the noises, to the bad grounding, the availability can be reduced. So
Yeah, excellent, excellent.
important.
So I did see on the chat, oh no, it's in the question and answers, is how important is string monitoring for string inverter, one inverter for about 10 strings? Maybe if each of you could, if you have an opinion, give a typed answer to that question. And you all mentioned monitoring, automation. Automation seems to be a high thing and stuff like that. So just to throw in a little bit of advertising for ATA Insights, tomorrow there'll be a webinar in this O&M for PV series that's entitled State of the Art Monitoring, Automation, and Data Analytics. And it's going to look at things like wireless communication systems, how to effectively use the data that you collect, and then actually, hopefully, we'll be talking also about some real-life case studies. That's a presentation that will be going on tomorrow at the same time as today. And I believe it was posted by ATA, the link to join that just recently in the chat box. So I don't see any other questions right now, and I believe we're just about out of time. And I certainly appreciate and congratulate your three panelists. I think you did a wonderful job. I thank all of the attendees for your questions and your attentiveness, and certainly look forward to hearing from everyone in the future.